prove by induction that 1 times 3 plus 2 times 4 plus dot 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 plus n into n plus 2, close brackets, everything is equal to n into n plus 1, close brackets, open brackets, 2n plus 7, close brackets, divide by 6 for all integral values of n. Now we are going to use t, a, p, and e, okay? And the t is for testing, so we are going to test for n is equal to 1. So on the left hand side, we have our formula as n into n plus a 2, close brackets, okay? So where there is n, we are going to substitute a 1. And when we do it, we are going to have 1 into, when we substitute here a 1, we are going to have 1 plus a 2, that is a 3. So 1 times 3, the result is a 3. That is on the left hand side. Now on the right hand side, we have our formula as n into n plus 1, close brackets, open brackets, 2n plus 7, close brackets, divide by 6. So where there is n, we are going to substitute a 1, okay? So we shall have 1 times, now when I put here a 1, I'm going to have 1 plus 1, that is a 2. Then times, when I substitute here a 1, I'm going to have a 2 times 1, that is a 2. Then plus a 7, that is a 9. Everything divided by 6. So 1 times 2, that is a 2. 2 times 9, that is 18. 18 divided by 6, I'm going to get a 3. Now when I compare left hand side onto the right hand side, it is clear that both sides are what? Are equal. And when I see this happening, I'm going to say, hence, the formula is valid for n is equal to 1. Now, since that is true, I cannot conclude that it is just true for all values of n. So I'm going to assume we are going to assume that the formula is valid for n is equal to a k. So I'm going to get this n equal to k. I substitute into my formula where there is a k. So when I do it, I'm going to have a 1 times 3, then plus a 2 times 4, plus dot dot dot, plus where there is n, I substitute a k, then I have a k plus a 2, then this is equal to, on the right, I have a k into a k plus 1 into a 2k plus 7, then everything divided by a 6. Now, we are done with testing, assumption. Now we are going to go for a proof. So we are going to say proof that if the formula is valid for n is equal to k, comma, then it must be valid for n is equal to a k plus a 1. So we are going to get n is equal to k plus 1. We substitute into our formula where there is n. So when we do that, we are going to have a 1 times a 3, then plus a 2 times 4, then plus dot dot dot, plus. Now our last term was a k into k plus a 2. But on adding a 1, it ceases to be k into k plus a 2. So we are going to add, we are going to get this k plus 1. We substitute on the left where we see n into n plus 2, close brackets. So this is a k plus 1, open brackets, a k plus 1, then plus a 2. And on the right, this is equal to, where there is n, I'm going to substitute a k plus a 1. So this is a k plus 1 into, now when I put here a k plus 1, I'm going to have k plus 1, then plus 1. So this is the same as saying k plus a 2. So I substitute it there. So when I get a k plus 1 and I substitute it here, so I'm going to have a 2 into k plus 1, then plus a 7. So this gives us a 2k, then plus 2 plus a 7. But 2 plus 7, that is a 9. So we have 2k plus a 9, everything divided by a 6. Now, we observe that 1 times 3 plus 2 times 4 plus dot 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 plus a k into a k plus 2 close brackets is the same as saying k into k plus 1 close brackets open brackets 2k plus 7 divided by a 6. So where there is 1 times 3 plus 2 times 4 plus dot dot plus a k into k plus 2 close brackets, I'm going to substitute a k into k plus 1 open brackets a 2k plus 7 everything divided by a 6, then plus a k plus 1 open brackets k plus a 3, everything is equal to the right hand side. So we are going to simplify the left hand side. So what I'm going to do first, I'm going to make sure that they have the common denominator. And how am I going to achieve it? I'm going to multiply by 6 and then I divide by a 6. So when I do it, I'm going to have the common factor is k plus 1 because it is happening here and the same time there. So I pull it out. And when I pull it out, here I'm going to be left with a k into 2k plus a 7. So when I get this k and I multiply through this bracket, I'm going to have k times 2k, that is 2k squared, then plus k times 7, we obtain a 7k, then plus, here, when we pull out a k plus 1, we are going to be left with 6, multiplying this bracket, so we shall have a 6k, then plus a 6 times 3, that is 18, everything divided by a 6. So we want to prove that this function or this expression is equal to this. So I'm going to add the like terms. So when I do it, I'm going to have a k plus 1 into 2k squared, then plus 7k plus 6k, we get 13k, then plus 18, everything divided by a 6. But when you look onto this bracket, it is clear that we have a quadratic expression. Okay, so we need to factorize that expression. And how are we going to do it? We are going to begin by finding the sum, which is the coefficient on k, that is a 13, and then the product, which is a 2 times 18, and that is a 36. So we need two factors such that when we add them, we get a 13, and when we multiply, we get a 36. And it is clear that those factors are a 4 and a 9. So when we add 4 onto a 9, we get a 13. Now, when we multiply 4 times 9, we get a 36. So we are going to say that this is equal to a k plus 1. We open up the brackets. So we have a 2k squared, then plus a 4k. So we are going to split this 13, then plus a 9k, then plus 18, everything divided by a 6. Now on grouping, we shall have that, okay? Now after grouping, we realize that each bracket has a common what? Factor. So let me begin with the first bracket. So we have a 6 here, a k plus 1. Now, when we look at this bracket, 2k is common. So I'm going to factor it. And when I finish factorizing, I'm going to realize that here I'm going to be left with a k, then plus a 2, then plus the common factor between a 9k and 18, it is a 9. And when we factor out a 9, we are going to be left with a k plus a 2. Okay, now after factorizing, we realize that a bracket including k plus 2 is common. Also, we do factorization, and when we factor it out, here we are going to be left with a 2k, and plus when we factor out a k plus 2, here we are going to be left with 9, everything divided by a 6. So when I compare this right hand side with the left hand side, it is clear that the two sides are equal. And when I see that happening, I'm going to conclude by saying, hence, the formula is valid for n is equal to 1, 2, and other values of n. That's why they are saying for all integral values of n.